Welcome to aminacademy.com. In theory of equations, let us discuss about fundamental theorem of algebra. What is that? The fundamental theorem of algebra states the following. A polynomial function of f of x of degree n where n is greater than 0 has an n complex solutions for the equation f of x equals 0. Note this term here, zeros and roots are synonyms, same meaning, with solution as used in the context in this video. Now we should already know the polynomials can be described by their degrees. For example, the polynomial x power 3 plus 3x square plus 6 minus 8 has the degree 3 because its largest exponent is 3. So this equation have 3 solutions or 3 zeros. Now let us discuss further about fundamental theorem of algebra. Look at here. A fundamental theorem of algebra proven by Carl Friedrich Gauss states that every non-constant single variable polynomial with complex coefficients has at least one complex root, meaning it has exactly n roots, counting multiplicities in the complex numbers. Fundamental theorem of algebra is about degree of polynomial is always equal to number of roots. Here's some more details about what it states. Every polynomial equation of degree n with complex number coefficient has exactly n roots or solutions in the complex numbers. Key concept: polynomial, an expression consisting of variable and coefficients involving only the operation of addition, subtraction and multiplication on non-negative integer exponents. Complex numbers, numbers that can be expressed in the form of a plus bi, where a and b are real numbers and I is the imaginary unit. That means square root of -1. Roots or zeros, the values of the variable that makes the polynomial equal to 0 is called a root. Multiplicity, the number of times a root appears as a solution of the polynomial equation. Example, consider the polynomial equation x squared plus 2x plus 1. This is a quadratic equation of degree 2. So according to the fundamental theorem of algebra, it should have 2 roots. Factorizing this equation, that is x squared plus 2x plus 1 is x plus 1 into x plus 1 equals 0, which means the roots are x equal to -1 with multiplicity 2, that is it's repeating. What is its significance? The theorem guarantees that any polynomial equation of degree n has exactly n solutions in the complex plane, which is fundamental concept of algebra. It helps in understanding the behavior of and properties of polynomials. Now let us do one theorem regarding, look at here, every polynomial of degree n, look at this theorem. Every polynomial of degree n has n and only n zeros. Now, for example, look at this polynomial f of x equal a0 x power n plus a1 x power n minus 1 plus dot 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 with a n, where look at here, a n is not equal to 0, must be, the term must be there. This degree have n is greater than or equal to 1. This is a fundamental theorem of algebra. F of x has at least one zero, that is alpha 1. Let alpha 1 is 1 0 of this polynomial, then we can say f of x can be expressed x minus alpha 1 is a factor of s, is a factor of this polynomial. Now, therefore, we can express f of x equal x minus alpha 1 q1 x, where q1 of x is a function of degree n minus 1, of degree n minus 1. Already the degree is n. Here why n minus 1 comes? Because already one factor is x minus alpha 1 is multiplied with. In general, we can write f of x equal x minus alpha 1, x minus alpha 2 and q2 x, where q2x is what? Is a polynomial function, is a polynomial function of degree n minus 2. Why? Because two factors already, which is x minus alpha 1 and x minus alpha 2 is multiplied with q2x. Therefore, the q2x is having degree n minus 2. Therefore, generally we can write, in general we can write f of x equal an x minus alpha 1, x minus alpha 2, then x minus alpha n, where alpha is any number other than, that is here alpha, these are the zeros, alpha 1, alpha 2, alpha 3, like alpha n's are zeros. Now, so far we discussed about fundamental theorem of algebra and some explanation in that. We have done. Please subscribe our YouTube channel.